Hello friends, welcome back to Tech Nerd, and in this video we'll learn how to use multimeter.
Renderforce.com.
Okay, digital multimeter. In last video we saw that unboxing of this multimeter. Okay, so now in this video we'll see how to use this multimeter. So here we got our main display. In order to on this multimeter, just we need to rotate this knob, right? So it's ready to use. So we got these two probes. Now where to insert it? So this is the black probe. This goes to common here, in common, right? Next we have the red probe, which goes to volts, ohms, milliamps. Because we are not measuring current above 10 amps, right? 10 amps DC. So since we are measuring below it, we need to connect our red probe here. If we are measuring current rating approximate to 10 amps, then we need to connect this probe here. Okay, as of now we'll keep here. Okay, so now we connected. So these are the probes to check the process, and now let's see what's the use of these probes and how can we measure. Okay, firstly we'll see the continuity option. Here you can see the symbol. Here as you can see the symbol, this buzzer type of symbol. With this we can measure continuity. So we need to rotate this knob to this buzzer. Okay, so now the knob is at buzzer, so we can measure the continuity. So just see these two, we have these two probes, we need to connect it. We can hear the sound, right? So the wire is not broken. If we take the similar wire here, so if we take this, it will go. We can't hear any sound, right? If we again connect it here, we can see sound, right? The meter shows 0, meter displays 0, and it gives some noise, right? Again you can see now the meter is displaying 1. If we connect it, it will display 0, obviously. That means that the wires are not broken from anywhere. Okay, next we will see how to measure voltage. So for that we got a 9 volts battery. You can see here we got this 9 volts battery. So in order to measure the voltage, we need to place this knob to voltage. Since our battery is of 9 volts, we will place it to 20 because we don't have any other option. So right, now place this positive terminal to positive of the battery. Here you can see that this is positive. So just place it over here, and the other end to negative. So you can see that the voltage displayed is 9.15 volts. That is approximate voltage. If we connect vice versa, we can see that a negative voltage appears, right? Negative minus 9, right? So this is how we measure the DC voltage. So let's keep it aside. Now we'll test how to measure resistor, right? This is our resistor. So in order to measure, we need to keep it near 2K. Now as of now I'm keeping it at 2K. So place your probes either end of the resistors. So you can see that it is showing 0.119. So it is much less than 2K, right? So let us decrease more. Right, after reducing it to more, we can see that exactly it is 120 ohms. Approximately it is 120 ohms, right? 117, 118. So approximately it is 120 ohms. Since we kept our knob to 200, so it can measure up to 200 ohms right now. So we can see that this resistor values around 120 ohms. So now we know how to measure resistor. Now we'll see how to measure what we call current. So in order to measure the current, we need to go here at 2 milli. So now we are measuring current less than what we call 20 milliamps, right? Less than 20 milliamps or 200 milliamps as of now. Means less than 10 amps. So no need to change this probe. Directly take your battery and a resistor, connect it to negative terminal or positive or whatever you want. Then connect this probe to your positive terminal. Then the other end to the, this is not connected properly. Alright, now connect the other probe. So we can see that it is showing 68 milliamps. So as of now, after connecting this resistor, that is 120 ohms resistor, we can measure a current of 68 milliamps. So if we directly measure the current of this battery, we can see that the voltage is 9 volts, right? And there is a formula in which states that V equal to IR. So now we didn't connected any resistor. Directly we want to measure current. So it must be equal to 9 amps. Okay, but it won't be equal to 9 amps. It will be less than 9 amps. Why? Because there will be an internal resistance. Because of that, it will be less than 9 amps. So we need to connect it to 10 amps probe knob. Now place it on 10 amps. Place your red probe to positive terminal and black one to negative. So you can see that it is showing 1 amps. As of now it is showing 1 amp because of its internal resistance. If we take another battery, of the same kind, then we will see what's the current reading is. It's much more less than that. Why it is? We got two batteries, right? One this and another this. If we measure current reading on this, we'll get 1 amps, and when we measure here, we get less than that. You can see that. If we measure this, we are getting approximately 12 amps, right? If we measure here, we are getting 1 amps. So why is that? Because of power. So battery has some power, right? Based on power, we can say that how many days it will last. So when the power is directly proportional to VI, right? Voltage into current. Voltage remains constant, current varies. If current varies, the power automatically reduces and the battery life reduces. So that's the reason why the current is low in one battery and high in another battery. Okay. So we got to know how to measure what we call current. Now we'll see how to measure the HFE value of transistor. So here we got two transistors, right? Two transistors, but in this we have one 557 BC557. This one is BC557 and this is BC547. So BC547 is a NPN transistor, while BC557 is a PNP transistor. So according to that, we need to measure based on which is PNP, which is NPN. First we need to find those two, then we can measure it. Okay, so now we got PNP transistor, right? BC557. If we connect this PNP transistor, first we need to place our knob to HFE. Then we need to, the first terminal here is collector, then emitter base, collector emitter base, sorry, collector base emitter. Okay, so we need to, if we connect here, let us connect here. Oops, we can't see any output, right? So if we connect here only, then only we can see the output, right? You can see the output, right? And now I didn't told you about this hold button, right? When we press this hold button and if you remove this, then the value remains as it is, 473. So now I didn't kept any transistor over here. You can see that nothing is there, but still the value is there. So while using, we can hold it to write the value. If I press this again, the value goes to 0. Okay, now again if I keep this in the upper slot, let's see what's the output. Output is 0. Why? Because this is an NPN transistor. So we can't keep NPN transistor on, sorry, this is PNP transistor, we can't keep it in NPN slot, right? So here we got our NPN transistor. So if we keep this NPN transistor in NPN slot, then we can measure the value. So for this we have approximately 370 or 330. So when I press hold button, we can see that reading is 333. So we measured the HFE value of our transistors. So let us get back. Now when I press this, we can see a light. Okay, if you can't see, I need to bring this bit closer so that you can see, right? Now you'll be able to see, right? You can see, right? This is a small light kind of thing. In night you will be easily see this light. Okay, so here is what we saw how to use it. Thank you for this tutorial, watching for this tutorial. Please don't forget to like, share and subscribe. Thank you.